Hi guys, welcome back to another video. So in today's video, we are going to be having a look at a computer science post paper, and we will be having a look at the October paper. This is variant 1 of paper 1. So this is the theory paper. And further ado, let's just begin. It's been some time since I've done a past paper video for computer science, so I thought this would be much better. So let's see. Binary is a number system that is used by computers. Okay, we know we have three number systems that you need to know for computer science. We have denary, we have binary, and we have hexadecimal. The computers use binary. We know that. We learned that in chapter 1. Basically, binary consists of 0 and 1. Okay, only 0 and 1. Okay, so A is saying tick one box to show whether the binary is a base 2, a base 10, or a base 16. Now, binary, as I told you, consists of only 0 and 1. Therefore, it should be or has to be base 2. Okay, base 10 is denary, base 16 is hexadecimal, and those are the only number systems that you need to know for this syllabus. So, you don't have to try to learn any other number system in this syllabus. So let's move on to the next question. It says hexadecimal and denary are number systems that can be used by programmers. Okay. It says convert these four hexadecimal values into denary values. Now you can approach this question in different ways. Either you can convert the hexadecimal to first binary and then binary to denary. So, some people just prefer to work with binary because it's a, much more easier way. But there's also another way which is much more simpler, is using the help of directly converting hexadecimal to denary with the help of the number system 16. So initially what you're supposed to do, okay, so for the first one it's 0, 9. Now you can't ignore the 0, okay, because it's hexadecimal. Some people just say it's 9. 0, 9 and 9 are completely two different stuff. Okay, but how you're supposed to convert this is going to be, you have to multiply 9 with 1, and you're supposed to multiply 0 with 16. Okay, the reason you do this is because hexadecimal is a number system with 16, with a base of 16. Therefore, it has to be 16 to the power 0, 16 to the power 1, 16 to the power 2. 16 to the power 0 is 1. 16 to the power 1 is 16. 16 to the power 2 is 256. So to convert a hexadecimal value to a denary value, okay, which these are denary values right here, we are supposed to multiply each digit with the corresponding denary value. So 9 would be here. I would put it here and here, right? So 9 times 1 is 9. 0 times 16 is 0. So the answer for the first one is 9. So it's as simple as that. And all you need to know is this stuff: 1, 16, and 256. After that, it becomes quite easy, as you just have to multiply. Okay, so that is how you do it. Let's move on to the next one. You can pause the video and try this yourself, and then give it a go. So we have 1 and 0. So you start off by multiplying 0 with 1 and multiplying 1 with 16. So that will give us 16. So the answer is 16. So quite simple. And usually in computer science, because you're not allowed calculators, they give you very easy values, and mostly for these types of questions they only give you two values, because multiplying a number with 256 can be time consuming and you can make many mistakes. So the main motive is not doing maths, is it? Because the main motive is to convert hexadecimal to denary and not do some complicated maths. So basically they usually give you only two values. Okay, the next one is 28. To convert to 28, you do 8 times 1 and you will add 2 times 16. So 8 plus 16 times 2 is 32. So 8 plus 32 will be 40. Okay, quite simple. Now here we have another looking value, a and 1. Now what is this a, you might ask me? Now in hexadecimal, after 9, okay, it goes to a, b, c, d, e, and f, whereas a is 10, f is 15. Okay, that is how you do it. Okay, so this is 11, this is 12, 13, 14, 15. So a would be 10 here, so I would do 10 times 16, okay, plus 1 times 1, which is 1. So that will be 10 times 16, which is 160, plus 1, which is 161. So the answer is 161. So some easy 4 marks right there. The first page is usually just basic, knowledge about computer science. Usually it's about number systems. And yeah, sometimes it could be, either about MAC address, which relates to hexadecimal and stuff like that. Maybe it could be about registers, which deals with binary. Okay, so let's see. Here's another question. Magda has a mobile telephone and she's using a touchscreen on her telephone to send emails to a customer. The touchscreen breaks, stopping Magda from using it to type her email. So it breaks. It says identify one other input device that would be built into the mobile phone that Magda could use to send an email to her customers. Now, in a mobile phone, the other input device that I can think of is a microphone. Okay, this is the most reasonable one, because if you talk about a keyboard, do you use a keyboard in a mobile phone? That's no. So even a mouse, you don't use it. So the only other option would be microphone. The touchscreen operates by using conductive properties. We have 3 types of touchscreens, don't we? We have the conductive, the resistive, and the infrared that you need to know for this syllabus. As you can see here, the resistive, capacitive, and infrared. Because it's conductive properties basically means our hands have the conductive properties. So when it touches the screen, it basically forms a circuit. And the reason is because of the capacitive screen. Okay, resistive is when the screen has 2 layers, and when I click on this, it will join with this other screen, making it resistive. And infrared just helps use of grids, and as soon as I click my hand somewhere, for example here, it will calculate the coordinates of where I've clicked it on the screen, and that is infrared. So the answer for this question though is capacitive, because it uses conductive properties. So those are the 3 screens you need to know. You should also know the benefits of each of them. The benefits, you look at the price, you look at the capability with other tools, for example a stylus and stuff like that. If you don't know those, go and have a look at the chapter where I talk about the screens. It'll be down in the description. I've made an entire 2-hour video talking about the entire theory segment for this paper. So go have a look at that. Okay, I cover all the 8 chapters in detail. So go have a look at that. Anyway, the next question is saying Magda is listening to music on her mobile telephone. When she receives a telephone call, a signal is sent within the telephone to stop the music and outputs that a call has been received. So what is this signal? We have 2 types of signals that you need to know in computer science. We have the buffers and we have the interrupts. So in this case, an interrupt is a signal that will tell the microprocessor, which is in the phone in this case, to stop whatever it is doing and focus on that problem. Okay, because whenever you get a call on your telephone, whatever you're doing, it will stop and that telephone screen will come on your screen. So the reason is because of the interrupt signal. So the answer is a signal called interrupt. Okay, whereas we also have a buffer. A buffer is simply, when you are going for a stream, sometimes if you have noticed on the loading screen, there's a faint line that's moving ahead and ahead. That is called a buffer, meaning it is loading what is next before it's even arrived to that part of the video. Okay, the reason to that is so that we don't have buffers on our video. That's another type of signal. It's not necessarily a signal, but it's just used in computers, and you learn this with interrupts. So that's why you should know about buffers too. The next question looks like it's about error checking methods. We have about 5 error checking methods that you need to know. Checksum, check digit, parity check. We have ARQ, and I think those actually we only have 4. There might be some other ones, but these are the main ones. Okay, so it says 5 statements are given about these error checking methods. Okay, and we are supposed to tick the statement which applies to the checksum, check digit, and parity check. So let's see. So the statement, the first one is saying uses an additional bit to create an odd or even. So whenever you see odd and even, it should be parity check. Checks for errors on data entry. On data entry should be 2 of them actually, and that is only check digit. Checksum is a calculation. It doesn't check the error on data entry. It's a calculation done on both. Now you see, with these types of questions, you really have to be careful because there might be some columns with 2 ticks. Okay, so that makes it really tricky, because you need to understand that some places there can be 2 ticks, even though it's 5 marks, which can be a bit misleading. There can still be 2 ticks. Okay, so the next question compares 2 calculated values to see if an error is occurred. I just explained this. It is checksum and check digit. Will not detect a transposition error. This is a disadvantage of parity check. Sometimes they can ask, why can parity check not identify an error? The answer would be because it cannot detect transposition errors. The next question sends an additional value when the data is transmitted from one computer to another. That is checksum, because checksum, the main idea behind checksum is that it calculates a value before the transmission is taken place, and then it also does the same calculation on the data once when it has been transferred. And then what it does, it compares the 2 sets of data, and if they are the same, then there's no error. If they're different, there's an error, and an error message will show up to the user. Okay, so that's how all these error checking methods work. The next question, it says identify one other error checking method. So another error checking method that I mentioned was ARQ in the start, and I believe that's the only one that we have in the syllabus. So we have 4. Okay, our next question, it says Georgia is a wedding photographer, okay, and she wants to store 10 photographs on a USB flash memory. Okay, each photograph is 100 pixels wide, 50 pixels high. So that is key information for this question. So I'm just going to highlight it. And she has, of course, she wants to store 10 of these photographs. And one photograph is 100 pixels wide, 50 pixels high. It says the photographs are 8-bit color photographs. And she wants the total size in kilobytes. So it's currently in bits. She wants it in kilobytes. Okay. So it says for this calculation, you may use the unit of measurement of 124 or 1000. So any could be fine. 1000 is a bit more simpler, but you can also do 1024. It depends on what you want to do. So let's see. The first things first. You need to calculate how many bits each photograph has. Okay, or each yeah. So you need to know that. So let's first calculate for one photograph. Okay, 100 times 50. This is how many pixels. So this should be 5000, is it? Because we have 3 zeros, so 5000 pixels. Oh, sorry, 5000 bits, because remember it said, yeah, so it's bits. But then to get it into 8-bit photograph, you have to multiply 5000 with 8 to find the total number of bits. Okay, so that will be 40,000 bits. Okay, so that will get us 40,000 bits. Now, how can you convert bits into bytes? Because you can't convert bits directly to kilobytes, right? You need to convert bits to bytes and then bytes to kilobytes. So how do you convert bits to bytes? We know that 8 bits equals to 1 byte. So hence 40,000, okay, 40,000 divided by 8 should give us how many bytes? So that should be about 5,000 bytes. Yeah, 5,000 bytes. Some easy maths here. Now, 5,000 bytes is only for one photograph. This is only for one photograph. We need for 10 photographs. So we have to do 5,000 times 10. This will give us 50,000. Now, 50,000 is in bytes. Okay, that would be the answer in bytes, but we want in kilobytes. And they have said you may use the measurement of 1024 or 1000. So I can divide this by 1000, or I can divide this by 1024. So if I do 50,000, okay, divide by 1024, okay, divide by 1024, for saving time, of course, you would do long division, but for saving time, I'm just going to use a calculator right now. 50,000 divided by 1024 is going to give us 48.83. So you would say 49 KB. Of course, you don't have to write remainders when doing the thing. So you can just write 49 KB. Okay, so that is how it works. And that's as simple as that. We move on to the next question. It says Georgia compresses photographs to store them on a USB flash memory. Okay, so it is important that the compression does not affect the quality of the photograph. So if it does not have to change the quality, then you would need lossless. Okay, because lossy, okay, we have two types of compressions, lossy and lossless. Lossy is when the data is permanently deleted. Okay, lossless is when you can retrieve it back. Okay, and it won't affect the quality. So lossless, okay, will keep the data there, okay, because we can't affect the quality, so we need the data to be there, while lossless will remove the data. So you can say here lossless, lossy, yeah, so we can say lossy compression will basically remove data permanently. Okay, whereas the lossless won't. Okay, and then you can, for of course it's 3 marks, so you need to give another point. You can say it will maintain the quality. Okay, there you go. That should give you 3 marks. These are one of the easiest questions. Usually it's just straightforward, you don't even need this list, but let's see. Georgia uses a digital camera. The digital camera takes a photograph and that is converted into a digital image. It says, complete the paragraph about the operation of a digital camera using the most appropriate terms from the list. Not all terms in the list may be used. Okay, so let's see. When Georgia pushes a button to take a photograph, an aperture opens at the front of the camera to allow light to stream in through the lens. Okay, because we have a lens in a camera, and to stream it through the lens, and this is captured by a sensor called a charge coupled, because nothing else can be a sensor, isn't it? Okay, digital to analog is not a sensor, lens not a sensor, light not a sensor, mirror not a sensor, pixel not a sensor, reflection not a sensor, sensor called a sensor, nope, storage is not a sensor. So the only sensor is charge coupled. Okay, analog to digital, remember, because it's saying it is converted to a digital image, so how can it be digital to analog? So it has to be analog to digital. So I'll write here analog to digital. Okay, and this converter will then convert each pixel into a digital value. Each pixel into a digital value, because a photo is in pixels, isn't it? So when you want to convert it, it will become a digital value, like what we just did in the previous question, whereby we calculated the kilobytes. Okay, we move on to the next question. Next question looks like it's about the von Neumann architecture and about the operating system, so it's part of the same topic. Tamaz stores confidential data on his computer. He says he uses the internet regularly and is concerned about his data being viewed by unauthorized people. He currently has one software method to stop his data from being viewed, which is a password. He wants to add another software method to help stop people from viewing his data, and he says state 2 other software methods that Tamaz could use to stop his data being viewed by unauthorized people. Now, another way is through the help of biometrics. Biometrics can also only be accessed by Tamaz using the help of a physical body part. And another way is by using encryption. So encryption, will ensure, or how encryption works is by converting normal data into ciphertext so that it is hard to decode it. Okay, there's a whole process on how encryption works, and you need to understand how encryption works, because many times they can even ask you, how does encryption work? There's a whole process about encryption algorithms, ciphertext, encryption key is public key is created, private key, same way to encrypt, decode, stuff like that. You need to know that and go revise that if you don't know. B, it says Tamaz's computer has an operating system. 2 functions of an operating system are file management and memory management. State 2 other functions of an operating system. So there's so many. One of the main ones is actually error handling. So error handling, and one of the errors, as we mentioned previously, was interrupt. Technically that's an error, isn't it? An interrupt is an error, so the operating system is the one that handles that type of stuff. Okay, and the next one you can say is it provides a user interface. Provides a user interface. So that is what operating system does. If it doesn't have that, then it won't actually provide a user interface. Okay, so anyway, the next question, it says 6 statements are given about the role of components in a central processing unit. It says tick to show whether each statement applies to the memory address, which is the MAR, the MDR, or the PC. Let's see. It is a register in the CPU. Now, all of them are actually in the CPU. We learn all of them under the CPU. The next question, it holds the address of the next instructions. The next instruction, it would be the PC. Okay, that's the main one, but I think even the MAR does that. But PC is the main thing. When you're told to define PC, this is what you're supposed to say. It holds the address of the next instruction to be processed. It also it holds the address of the data that is about to be fetched from the memory. So if it's from the memory, it should be MAR. Okay, it could also be PC, but the main one is MAR. It holds the data that has been fetched from the memory. So it's already been fetched, that's MDR, because we know in the von Neumann it moves from the MAR to the MDR to the CIR. Okay, we know that. Okay, the next one, it receives signals from the control unit. What receives signals from the control unit? All of them actually receive signals by the control unit, and this is done by the buses. Okay, we have 3 types of buses. I don't want to go to that, but yeah, we have those 3 buses. Okay, the next one, we have the control bus that does that. Okay, anyway, it uses the address bus to send an address to another component. So this is one of the buses, and this is done by either the MAR or the PC, because we know in the steps of von Neumann, the PC to the MAR with the help of the address bus, the MAR to the MDR, okay, usually by the data bus. Okay, and then the MDR to the CIR. So that's how it basically works. Identify the component and the CPU that carries out calculations. So what carries out calculations? We say this is the ALU, arithmetic logic unit, but you can just write ALU. That's the main component that does calculations, and everyone really knows it as the one that does calculations, but it does many other tasks. But yeah, mainly it does calculations. Tick one box to identify if an internal solid state drive, so this is the SSD, is primary, secondary, or offline. Now we have learned 2 secondary storage devices, SSD and HDD, so the answer is secondary. Okay, and the reason to this is because it's first of all non-volatile. Okay, even HDD is non-volatile. Both of them are non-volatile, and it cannot be accessed by the CPU, not directly accessed by CPU, while the primary, which is the RAM and ROM, is accessed by the CPU. Okay, let me just give you some examples of each. Primary is RAM and ROM, secondary is SSD and HDD, offline could be CD, DVD, Blu-ray, and stuff like that. Okay, so that is what you need to know. Sometimes they can ask you to give examples, sometimes they can even tell you to define what primary storage is, what secondary. They can even tell you, is it non-volatile, volatile. You need to be prepared for all of that. Now it says describe the operation of an SSD and how it stores. Okay, quite simple. First of all, it's called flash memory. Okay, flash memory, that will give you a mark. The next thing is you say, because it's flash memory, data is flashed. Okay, data is flashed onto the chips, or wherever it's stored, and it uses NAND, okay, technology. It uses NAND technology, and then you can just say uses transistors. This is like the ideal answer, okay? And sometimes in computers, actually most of the times, questions are just repeated, okay? And if you've done a similar type of question, like I can give you an example. If you've done many past papers for computer science, I'm sure you must have come across the question about describe the role of a browser. It's so common in these past paper questions that, it's almost, definite that it'll come in your next exam, okay? Because it's quite common. And sometimes it's 4 marks, 3 marks. They give you different types of examples. So, it's mainly almost the same answers for each of them. Like, it uses HTTP, HTTPS, then there's all the IP address from the DNS, stuff like that. Those types of questions are really common, and they have an ideal answer that you just have to give. Next question looks like it's about what? Translators and compilers and stuff like that, isn't it? So let's see. Victoria develops a computer game to sell on a gaming website, okay? And she's writing her program to using English-like statements. English-like statements, the first thing that should come into your mind is its high-level language. So I know already the first question is high-level language, okay? Because it is a programming language. We have two, low-level and high-level, okay? Then we have the compilers, the translators, and the assembler. So Victoria uses two different types of translators when creating the program for the computer game. She then says, state which translator is most suitable for the given task. So she wants to create a program for the computer game. The computer can understand which one. Okay, actually, it's saying what are the benefits of the translator. Okay, so we can give any. We can say either it is interpreter or a compiler. So I think interpreter for now, and then I'll just talk about the compiler later. So interpreter is line by line. I'm just going to make it short. Line by line, it basically does line by line, and it is easier to debug because it's telling us benefits, not how the translator works. So easier to debug. Okay, and the other point that you can give is errors are immediately reported. That's why it is line by line. So errors immediately, it is immediately reported. Okay, so yeah, but for compilers, you would say all errors are reported in a single report, meaning at the end of the compiler, you are given an executable file or a report with all the errors, and that means you can fix the errors at the same time. The next question, it says that to translate the final program and upload it to the website for distribution without the source code. For that, you would use a compiler because the compiler will make an executable file, and this executable file, is like that. It can be used for distribution, and also so that the source code cannot be stolen, because whenever you're putting anything on the website, you have to ensure that the source code cannot be stolen, so people cannot replicate or steal data from your website. So the translator would be the compiler. Okay, and the benefits for this would be it creates an executable file, so exe file, and then source code cannot be stolen, or yeah, that's that. Question 9, it says this looks like it's about microprocessors and stuff like that, sensors. And yeah, okay, so let's have a look at this. So it says a washing machine uses sensors and a microprocessor to control the washing cycle of clothes. It says a sensor is used in each of the given tasks. It says identify one suitable sensor that would be used for each task. So quite easy. Sensors are really easy. There are like 5-6 sensors that usually come in these exams. So let's see. Checking the water is 30 degrees. 30 degrees is temperature. So sensor is temperature. So, it's so general, which, computer science is quite a general topic, because computer science is used in our day-to-day lives, right? All the appliances, also the device that you're watching this video, you already know about the device. If I don't know if it's me or I think most of this knowledge, like the simple knowledge, is we already know, isn't it? Like the next one is checking the water acidity. So if it's acidity, we know it's the pH sensor, right? And then the next one, checking the weight would be the pressure sensor. Okay, for those people who play a game called Minecraft, which is quite popular, you know about the pressure sensor, isn't it? Some pressure plate whereby when you stand, the door opens, isn't it? So even these games are actually, redirecting to you to some computer science. So it's quite simple. So basically it is pressure sensor. Okay, we move on to the next one. It says describe how a sensor and a microprocessor is used to make the water remain at 30 degrees. Now these types of questions, they have a similar type of way to approach these questions. Usually they come to about 6 marks, 7 marks, 5 marks. And it's a simple way to approach this because it's almost similar for all of them. Okay, because the first things you would say is the sensor, which is maybe the temperature sensor, but you could just say sensor sends data, okay, to microprocessor. For almost all these questions, this is always the first line you should write. Okay, then you say data is converted from analog to digital with the ADC. Okay, and then you can say the data is compared. This 3 lines is usually the first 3 points you would give, and that would give you sorry, data is computed. No, data is compared. Okay, this is usually the first 3 marks that you get. Okay, now it's saying what will the microprocessor do, or why it should remain at 30 degrees. What should it do? So let's see. You can say actuator can be used for the on and off. Now any question that deals with moving parts or something related to do this, do that, close the door, close this, you need an actuator, so you would mention about the actuator. If data is at 30, then no action is taken. You can mention that. I'm just not going to write it, but you can write that. And then you can always write the last line, it is a continuous process. Sometimes you're not given marks for that, sometimes you are, but in this question you are. So it's always safe to actually do this. There's no harm in writing that. So write it's a continuous process. You should get a mark there without even doing effort. So these types of questions, it's so straightforward because it has a similar format for almost all questions. Number 10, it says consider the following logic statements. Okay, and we're being given a logic statement and we're supposed to make a logic circuit. So that's quite simple. All logic gates must have 2 inputs. Okay, of course. Okay, so let's see, A or B. We can start off with A or B. Okay, because that's the first one. So my diagram will not look the best, but I will try my best. Okay, so an OR gate looks like this. Okay, that's a terrible drawing, but please bear with it. This is joined with this. Okay, that means it is joined with B XOR C. So I'm going to draw off B XOR C first. B XOR C is drawn like this, with 2 lines actually, and then and this B XOR C is not, so I draw a NOT gate right here, and it is joined by the final thing is an AND gate. So it's joined by an OR gate. So this is joined by an OR gate. Okay, and then finally C is joining, oh, bad line, very bad line. C is joining with this to make an AND gate. Quite a bad drawing, but hopefully you understand that. So that's how it works. Okay, because the main thing is about the brackets. Let me tell you why some people can make a mistake here. So let me just zoom it in, okay, to this. Okay, look at this. Okay, hopefully you guys can see. First things first, look at the brackets. This is in brackets, isn't it? Let me use a highlighter. The first part is in brackets, meaning they have to be together. Okay, B XOR C. That's why I started with that. After that, you can see what's next in the brackets. Next in the brackets is NOT. It's in the brackets within this. This is the next bracket. That's why it's like that. And finally, the last bracket. Okay. The last bracket is this. This is joined together, all together. You see, 2 lines here, all together. No, it's not this joining with OR. Okay, so it's this, the next bracket. Okay, and then finally it's the everything together. So look at the brackets carefully. Then the last one is like this. So for all the logic gates, it has to be having 2 brackets. Okay, it has to have 2 brackets. Okay, so that's how you can actually not make a mistake in relation to that. Okay, so hopefully you've understood that. It says state the name of a logic gate that does not appear in the logic statement and draw the symbol of that. So I think I've not seen a or NOR gate, is it? And a NAND gate. So it's only telling us to draw one. Oh, oops, very bad drawing. So I'll draw the NOR gate. Okay, that's the NOR gate, and just write NOR gate there. Okay, we're supposed to do truth table now. Okay, so let's see, how many logic gates do we have? We have 5. Okay, and always I usually tell the key to this, to see if you're correct or not, look at the marks. 5 marks meaning 5 logic gates. If you don't have 5 logic gates, then you made a mistake, most likely, but not a must. Okay, because sometimes there can be another alternate route, but yeah. Okay, yeah, so anyway, let's see, we're going to split it to 5. Okay, so we're going to write 1, 2, 3, 4, and 5. Let's start with 1. Okay, I don't know if this is how you guys do the stuff, but this is how I do it. List each one. So this is 1, this is 2, this is 3, this is 4, this is 5. Okay, that's the first step. Second step, okay, it's a OR gate of A and B. OR gate meaning addition gate, so you add everything. Okay, it's the addition gate. The next one is 2. 2 is was this a XOR gate? Yeah, this is a XOR gate of B and C. B and C, XOR gate. So we know likes is 0, unlikes is 1. Okay, let's see, it's B and C, is it? Yeah, so this is 0, 1, 1, 0, 0, 1, 1, 0. Number 3, it is a NOT gate, very easy gate. It's the opposite of 2, so that will be like this. Okay. Number 4 is an OR gate of 1 and 3. So an OR gate of 1 and 3. 1 and 3 is addition, so it will be like this. Okay. Finally, number 5 is a AND gate of 4 and C. So 4 and C, we multiply them together, so this will be 0, so it will be 0, this should also be 0, this should be 1, this should be 0, this should be 1, this should be 0, this should be 1. Okay, so finally the answer is 0, 0, 0, 1, 0, 1, 0, 1. Okay, that is how you do it. Very simple, very easy. Number 11 says the table contains descriptions relating to web pages and the internet. Okay, and it's then telling us complete the table with the correct terms for the given descriptions. A language used to create a web page, that is HTML. The type of software application used to display a web page. The type of software application that's used to display a web page is called a browser. Okay, the browser, the web server, don't get yourself confused. The next one, an address given to a computer by a network to allow the computer to be uniquely identified. This is called the IP address because it's by the network. If it was with by the manufacturer, then that would be the MAC address. A text file sent by the web server to collect data about a user's browsing habits. That is called cookies. A cookie is a small packet that takes information from the user. It's not theft, but it's, just, sometimes when you open websites, it says accept cookies. That is what it means. The company then that provides a connection to the internet, that's called an ISP, and they give the IP address. So there you go. That marks the end of today's video and the end of the past paper. Hopefully you learned something new in this past paper. And computer science is always going to be improved if you keep doing past papers, because most of these questions are repeated and they're quite easy to understand once when you've done them before. So go through the content and then keep doing past papers. So hopefully this video helped you, and I'll keep doing these types of videos of different subjects. And also for this subject, I'll be putting the playlist for the theory and also the playlist for other papers that I've done down in the description. So thank you for watching this video, and I'll see you in the next one. Goodbye.